All right. So good morning, everyone. Happy last day of reInvent. Hopefully everybody enjoyed Dead Mass last night. I thought it was awesome personally. My name is Nate-Wiger. I'm a principal solutions architect for AWS. Quick background on me. Well, first off, just to double check, this is the deep dive into ElastiCache. So now's the time to double check, make sure you're not supposed to be seeing the Cloud HSM talk or something else. So my name's Nate-Wiger. I'm a principal solutions architect for AWS. At AWS, I focus on gaming customers, which is my background. Before joining AWS, I was actually at Sony PlayStation, where I launched a number of games on AWS starting in 2008. And so I joined Amazon a little over a year ago. One of the things I learned from my experience and also from talking with other gaming companies is the importance of caching, the importance of smart caching strategies when you're building a massive app that can horizontally scale out. So in this talk, I wanted to share a few things with you. So first off, I just wanted to kind of level set. This is a level 300 talk, but I think it's good to just make sure that we're all on the same page with kind of the context of what's happening out there in terms of apps we see in the wild, so we can kind of make sure to all be on this journey together, if you will. So we'll talk about some of those trends. We'll dive into some of the properties of ElastiCache, specifically, which is our managed caching service. And then we'll go about different ways to use caching in your app. There's a couple different ways, from lazy population to write-through. We'll cover those. And then we'll talk about scaling up, starting small, starting with a few, maybe even one node, getting out to you're running dozens or hundreds even nodes. And we'll talk about how to go through that process. And finally, we'll do a little Memcached versus Redis showdown at the end. Personally, I'm a big Redis fan. Coming from gaming, it's got some awesome applications for gaming. So we'll kind of talk about pros and cons, Redis versus Memcached. ElastiCache supports both now, as you're probably aware. So this is a graph, just to kind of kick it off, got from Business Insider. It just looks at the growth of different devices. I'm sure this is probably not news to you, but it's worth just looking at, because to me, it really drives the point home that you've got all of these different devices. You're seeing not just PCs anymore. You're seeing tablets. You're seeing mobile. You're seeing dozens of different form factors you have to deal with. And so what are the applications, or what are the implications, rather, of device fragmentation? And so the big problem with all these devices, you've got HTML, you've got native apps, you've got JSON APIs, your toaster wants to talk to your app now, right? Is the presentation is different on all of these, but the data is the same. So if you think about what we were doing just maybe 3 or so, or even 2 years ago with caching, a lot of it was rendering out full or partial pages of HTML. That's still a valid strategy. We'll talk about that. But you can't just constrain yourself to rendering out HTML views and sticking in a Memcache or sticking it on the file system anymore, because of the fact that you're presenting the data layer and you're presenting the data natively as well, right? So you have to do something at the data layer. We'll talk about strategies there. And of course, you're going to be using a CDN for all your static images, but that doesn't really help you with stuff like, hey, welcome back. If you think of your standard page, you go to CNN or whatever nowadays. Yeah, there's shared content in the middle. Maybe you can do some caching that applies to everyone, but up in the corner is just you. So how do you deal with mixing that in? Sure, these are challenges you guys are all facing as well. So compounding this is all of the different queries you're doing, right? All of the social tie-ins. Your friends want to see what you're doing. You want to see what your friends are doing. All these calls to external APIs. So you're making dozens and dozens of calls, whereas just a few years ago, the data was largely coming from your own database, and you were able to have a lot of control over it. Now you've got latency and other issues that are outside of your control, and caching plays a key part in making sure that that doesn't translate into a bad user experience. I don't know, it cracks me up. I always get updates about, look what I had for lunch, I'm sure everybody else does, and it just, now we have to deal with that as well. And traffic spikes is another one, the last one I want to mention in this context, and then we'll move on to kind of the nuts and bolts. This is from a guy who does analysis of social media streams, and I thought it was great in the context of caching. If you're running even a well-architected app that's got database layer that you've tuned, there's no way you can deal with a 2,000% increase in load in your database tier. It's just not possible, right? I mean, stuff is going to melt. So you have to have a good caching strategy there. You have to be involving that in all layers of your app. And so let's look at what that means. So when you think about caching, it's your main, what I like to think of as a mindset is that it's not something, obviously, that's authoritative. You're getting the data from somewhere else. You're taking it. You're making use of it. You're stashing it away and making sure that you can effectively use that later on in your application. A real simple diagram, right? You got your standard Web 2.0 app. You've got your MySQL database. You've got these external APIs. And then in the context of ElastiCache, Memcached, these kind of sit over on the side, right? There's a couple different layers, a couple different ways that people do caching. If you're thinking about where the CDN fits in, right, that's going to fit in on that kind of edge as well. But when we're talking about ElastiCache, it really kind of hangs off to the side, and it's up to your application to have the logic to be able to put and get keys out of there and make the best use of it. So highlights on ElastiCache, and if you saw the introduction to ElastiCache, or if you've used ElastiCache, this is going to be kind of repeat information. But it is our managed cache service. Supports Memcached or Redis currently. You can launch clusters of nodes. The nice thing that the service brings, as opposed to you installing Memcached yourself on EC2, is being able to manage the configuration in kind of this meta state, and then being able to deploy multiple nodes that have the same configuration. Scale up and scale down along the same lines. And then monitoring and alerts. Again, you could roll this yourself if you want to install Memcached on EC2, but the nice thing about ElastiCache is that it ties right in to CloudWatch and SNS in order to send you alerts to your phone, and you can take action depending on what's happening in production. So quick primer on Memcached. It's all in memory, as you're no doubt aware. It uses a slab allocator. It's not something you really have to be that concerned with, but you can impress your friends at parties, if they're those kinds of friends, and say, hey, Memcached actually uses a slab allocator. All that means is that it allocates in chunks and then internally divides up that memory, so it makes it faster to allocate memory. It's multi-threaded, can take advantage of multiple cores. Of course, there's no persistence, right? So you can't rely on storing it for long-term data. And it is kind of the gold standard. It's why we started out with ElastiCache, supporting Memcached first. So for the next few slides of this talk, as we kind of go through some of the details, we're just going to use Memcached as an example. Just that way we're not talking Memcached Redis over and over again. But from an ElastiCache perspective, the management is basically the same, right? You're going in, you're deciding which engine you want to use, Memcached or Redis. But the other features, such as alerts and configuration management, those are all the same regardless of Memcached or Redis. All right, cool. So if you haven't done it, quick walkthrough on firing up an actual cache. This is our console. This is from a couple days ago, so given how fast our console changes, it may look completely different today. But for the purpose of this talk, so you would click on the middle, ElastiCache, go in, click, hey, launch a cache cluster, pops up a dialog, say, give it a name. I use the extremely creative name Memcached. You probably want to choose a cooler name. And in your real life, a dev or test or production have a few different caches. Just selecting Memcached and the version. Going to start out with a small node. You can always change that later, grow it as your app continues to grow. And I'm going to spin up 2 nodes for the purposes of this talk, because I want to talk about stuff like sharding. I want to talk about balancing between multiple nodes, how to handle all that stuff. And then the last point I just want to highlight here, there's some VPC settings and stuff I didn't cover. SNS, so this is my, one of my personal favorite features about ElastiCache is that it does integrate with SNS. And the cool thing about integrating with SNS, it gives you a lot of flexibility. So SNS is our simple notification service, as you're probably aware. It has the idea of messages and endpoints. So you can send a message into SNS, and then you can route it to one or more endpoints. In the simplest example, this is usually used to just send you an email saying, hey, you're seeing a lot of latency, or your cache is getting full, or something like that. But in more complex kind of situations, kind of trickier ones, if you will, which we'll talk about, you can actually connect an SNS topic to SQS. And then you can have EC2 listeners that are listening onto your SQS queue and taking steps like dynamically changing settings and doing stuff like that. So it allows you to build a really kind of cool end-to-end cycle. We'll cover that towards the end. And then launch. So this is once it's up and running, takes a few minutes to get up and running. It shows up on your dashboard. And so if you click here, right, on the configuration endpoint, And you get this pop-up, and this shows you your 2 actual nodes. So those are the 2 nodes that ElastiCache actually allocated for us. We're just going to copy those DNS endpoints. We're going to open up our application. In this case, it's a Ruby app. I'm a Ruby fan. But obviously, you can use Python, PHP, Java, whatever else. So we're just going to open up our client, and we're literally going to paste those 2 endpoints in there. Real simple. And then we can set and get values, set, delete, all the common Memcache operations. Nothing proprietary about the Memcache that's running in ElastiCache. It's just straight Memcache. Anything that you would do with any other Memcache instance, you can do with ElastiCache. So when you're talking about multiple nodes, what does that look like? So we started out with a simple app. As you're adding nodes, those are all kind of peers from the application layer. It's not a tiered relationship. There's not a balancer between them. So your application then has to have the logic in order to actually figure out how to shard across those nodes. So I'll talk about a couple strategies you can use. So kind of the first strategy that a lot of people use, which you can find on lots of blogs out there, is they build an array of the servers, and then they basically take a hash on the key that you're going to save, and you do a modulo with the length of the server list. That's this part right here. And the idea behind the hash is to inject some randomness, kind of get a better distribution. And then the modulo, you're going to get back an index, right, 0 or 1, that points to which server to use. And then from there, it's just a simple matter of doing a lookup in the server list. You get back the server, and you can directly connect to it. And so if you put this in your application code, this would be one easy way to be able to balance between nodes. And the thing I want to point out about this is that you should never, ever do this. Like, this is a terrible way to balance across multiple nodes. So why is it so bad? So the reason why is if you work out the math on it, it's actually pretty terrible. What happens is you upgrade and you keep increasing nodes. You take the number of nodes that you're moving from, the number of nodes you're moving to, do a fraction out of those, and that is the number of keys that you end up actually reshuffling. So what does that mean? So if you're going from 3 to 4 nodes, this would actually reshuffle 75% of your key space. So envision what's happening, right? You're writing to your database, you're getting SNS alerts. It's saying, hey, watch out, cache is filling up. You say, hey, I've got just a ticket. I go into ElastiCache. I spin up another node. I go from 3 to 4 nodes. All of a sudden, I've flushed 75% of my cache, and my database tier just completely melts. Basically, the exact opposite of what you want to happen, right? So luckily, there's a solution. Smart people, smarter than me, have figured this out. It's called consistent hashing. Some of you are probably aware of this. And the idea behind this is you build a ring. You basically pre-partition your key space. And you build a ring, and then as you add and remove servers, if you look at the color coding up there, this is a diagram from Basho's site. They've actually got a good little write-up on it. So as you're adding and removing nodes, your actual ElastiCache nodes are going to be populating different parts of that ring. Okay? And there's a little bit of trickiness. There's some math involved, et cetera. So this is why a lot of people end up not doing this. They end up saying, oh, well, that's a lot of work. I'm a game developer. I'm a mobile developer. I don't have time to do that. I'll just do the modulo and move on, right? I'll come back to it later. And then, of course, they want to come back to it later, you know, when things are exploding. So the good news about this is you don't have to do this, because people have taken care of it for you. And these are examples of all of these client libraries that actually do consistent hashing for you, right? So the great news is that if you're using the Dolly library that I showed you from Ruby, if you're using Python, look at HashRing or Memcached. As far as I could tell, I'm not a Python expert, caveat, but as far as I could tell through reading the source code, the Python just straight Memcached library doesn't actually do consistent hashing. You have to use HashRing or Memcached. So this is a partial list. I'm sure there's others out there as well. But the point being is find a client library that does consistent hashing for you. And then if you think back to that example I showed you in the Dolly client, and just put your 2 servers in that list, and then the library will take care of doing the consistent hashing for you. And all you need to do is when you add another node, have your application be able to pick up that new node. We'll talk about that. And let the client library handle the consistent hashing for you. Don't try to fix it, and you'll be in good shape. All right. So far, quick recap before we wind off into the weeds a bit. So we launched a cluster, got the node names, put them in our client. We talked about sharding and hashing. And so now what? Right. So let's talk about what to cache. So we say, OK, we've got it all set up. I'm ready to do caching. Sounds great. What do we actually cache? And I say everything. So I say that a little tongue-in-cheek, but the reality is you have to use multiple different tiers of caching. It's not sufficient, as I mentioned earlier, just to cache the end HTML or just to cache even partial HTML chunks. You need to do stuff at the data layer. You need to be doing caching at all tiers. Luckily, it's actually fairly straightforward. You just have to kind of get in the habit, and we'll cover those patterns. So I say, database records, data layer, full HTML pages is still good to do. I mean, don't not do that, but it's just not sufficient by itself. Page fragments, partials, if you're using Rails or something like that, partials. Remote API calls is another big one. So talking back about the social APIs, you're making calls out to Facebook, Twitter, showing your friends. What you probably don't want to do is every single page load for a person visiting your site, make another call out to Facebook just to make sure they haven't changed their real name, right? You should be able to cache some of these basic details about a person, their name, they're from San Diego or wherever they're from, and then use that, right? Instead of TTL on it, which we'll cover, set a TTL on it and be able to actually leverage the cache for those remote calls as well. If you're using Facebook, Twitter, et cetera, they pretty much all have documentation where they give guidance on what they recommend in terms of how long to cache, how much they'd like you to cache, et cetera. Just refer to those docs, follow those practices, plug it into your app. It's fairly straightforward, but it's just all these kinds of things you just have to integrate when you're building your caching layer. You have to take them all into account. And so how do you cache it? So there's several different kind of ways, and they kind of break down into three different main buckets. So lazy population is the most ubiquitous. That's essentially you're not populating the cache until you actually have a cache miss. Your pattern is you've got your application, you check the cache, cache doesn't have the key, so you go to the database, come back, put it in the cache, and then you can use it from there on. There's also write-through, meaning that when you save a record, you say, hey, I'll just write it to cache right now. I know I just updated it, so here's the new record in cache. And there's pros and cons to both of those we'll look at. And then last, there's a timed refresh, which is you have a job maybe running out of cron or something else where you're just every X minutes or so going through and pulling out the top X values. Maybe if you're doing gaming, for example, you might have a background job that's running every 5 minutes and populating the top 100 leaderboard, stuffing that in cache. Crosses all these different records, so it's more efficient to have it running on a timed basis. We'll look at that pattern as well. So starting with the lazy population approach, this is a simple Python example. None of this code is designed to necessarily be reference code. You can feel free to use it, but any major framework, Rails, Django, et cetera, has their own adapters, so I would make use of that. But it's important to understand how, what you're actually doing, because then it actually makes sense like when you would use this strategy. So for this, our get user call, quote unquote, we're going to check the cache. If it's empty, no, we got nothing. We're going to do the actual DB query, get that back, and we're going to stuff it into the cache by user ID. And then with this example, we're returning a record in either case. And the reason we do that is then our application tier doesn't have to care whether or not we got it back from cache or got it back from our database directly, right? We're abstracting that away. Our app on up doesn't have to care about it. So it's a good pattern for being able to just have a piece of abstracted code down at your data layer. So later, if you want to swap that out for a different strategy, then you can change that, and you don't have to go through and disentangle everywhere where you've got caching code scattered around your application. So if you've only got time to do one thing, if you're pressed for time, as we all are, I would say just do this, ship it, and move on. And there's a few reasons why I say that. And the reason is, the big one is most data is never accessed. Meaning, you're updating your profile, you're updating this, you're updating that. And most data, if you kind of look at it statistically, most of the time people are not reading that data. So it makes sense to only use your cache memory for stuff that people are actually interested in. So by only populating it lazily, when somebody actually requests that value, then your cache remains basically fairly well optimized in terms of data that's important. As I said, it ensures the cache also is filled. It's a slight variation, actually. This is a slightly different point. So when you're first launching a cache node, right, it's just a big blank piece of memory. You've got nothing in it. So if you're not doing lazy population, if you're not having your app automatically kind of fill that cache up, then when you spin that up, you have to have some kind of scripts or some kind of intelligence to be able to figure out what to put in there. And it's definitely doable, and there's reasons you would do that, and we'll talk about that. But in terms of just keeping it simple, it's really nice to just have a baseline layer that you know you just launch a node, and it's just going to kind of fill up over time. The more and more people are interested in data, it's going to wind up in cache, and it's kind of just the hands-off, slam-dunk approach, right? And closely related to these is the fact that cache nodes fail, right? In addition to a cache node that you're manually spinning up, a new cache node might just croak. You might have to go in and replace it. And in that case, it'll just be lazily filled up as soon as it comes back online. And the big downside to this is the cache miss penalty, which you're probably aware of. But when a person first comes to a site and they've got all these cache misses, the page has the potential to look like it loads much more slowly. If they're coming out of cache, you might have a few milliseconds delay for each little piece of cache. But if you're checking cache and you're saying nope, and then you're going back to the database, and then you're saying OK, and then you're putting it back in cache, right? You're basically doing 3 trips. And then that can definitely impact, if you've got dozens of pieces on the page as you're doing that, it can make the page load rather than, maybe a few hundred milliseconds, maybe it's a few seconds now, right? But that being said, it is the best approach for most data just because it's slam dunk, it's simple, move on. And so when you're doing these strategies, start with this and then build up from there. So almost kind of the reverse idea from lazy population is the idea of a write-through cache. That is, you're making the choice to actually write it to cache. You know that the data is fresh. You're putting that intelligence into your app. So what does that look like? In the simplest case, you're going to save a user. You do that update statement, put it in your database, or if you're using DynamoDB, you would put that key in there. You do a set, put it into the cache, you return the record, and once again, your app doesn't care. It says, all right, update this guy's name, and then it can be used later on. So the advantage for write-through caching is that it does ensure that your cache is always current, which is not necessarily the case with a lazy approach. We'll talk about TTLs, but in the example I showed you earlier, you're just sticking something in cache. You're not doing anything to expire it, so it's very possible that that data is going to be out of date over time. Right? So you have to have some kind of strategy for actually expiring that data and moving it out of cache. A write-through cache ensures you absolutely have the most up-to-date data. And then there's also like the kind of nice part about the write penalty versus read penalty, meaning if I'm going in and if I'm updating my record and I say, oh, I just updated my name, I'm going to expect as a user for the page to load a little slower. Right? Like I'm updating data. Users have this idea that if they're changing something, they're actually saving it. It could take a minute. So that it's kind of a good trade-off there, that you're not impacting a random user that comes to your site and is all of a sudden seeing the page load a lot more slowly. You're just penalizing the one guy that's actually making the change. But it has all the kind of reverse downsides that laziness solves, which is that if you scale up, then your cache is empty. And you also run the possibility of having just a lot of data nobody cares about. Cache churn is another way to say it. We're just stuffing a whole bunch of data in there, and nobody's actually accessing it. It's just taking up CPU and memory. So ultimately, you really kind of still need the lazy fetch too. Right? So it's talking about, what was it saying, like if you just start with one thing, start with this, start with that, and then build on that, you still need the lazy fetch, even if you're also doing write-through caching. So the way to use these together is kind of like a combo move, right? Using a gaming term. So you want to do both, right? In a perfect world, if you have the time, and there's a lot of helpers out there in the frameworks nowadays, which is great, but you want to be able to actually go, and you want to be able to save the record, and then kind of talking about TTLs, which we haven't talked about yet. So we're going to save the record, we're going to get the user, et cetera. So quick detour on TTLs. So TTL is just, how long is that cache key going to live? Simple concept. And so on here, we're setting it both when we're saving it and when we're getting it back. And the idea being is that in either case then, the reason why TTL helps us out in both cases is that when we save the data, we're saying it's going to expire after a certain amount of time. Even though it is fresh now, it might not be fresh later. So then our lazy population can pick it up and refill it, which also helps in the case that a node goes down and needs to be repopulated, right? And then on the same token, if we actually do a git and the cache is empty because a node has been added or had to been replaced, then it's still setting a TTL again. So then on a future lazy fetch, then we can take advantage of it, or on a write-through, we can also increment that as well. So I don't think I have a slide for it, but I'll talk a little bit about TTLs. There's a couple different strategies for using TTLs. One of them, as shown here, is just to set it to some number of seconds, and then the key gets flushed out, and then it gets replaced. That's a great strategy, right? Nothing wrong with that strategy. Another way that's like a little more advanced that has its applications, most notably for stuff that you kind of want to live for a while, is you can set the TTL for a very long period of time, okay? And this will come into, as we talk about timed refresh on the next slide, this will probably make more sense. You can set the TTL for, say, a very long period of time if you're talking about a record that maybe spans multiple users. Okay, you say, okay, top 10 leaderboard, what I want to do is I want to set the TTL for 20 minutes. Even though I'm running a timed refresh every 5 minutes, I want the TTL to be 20 minutes. So I'm going to be replacing the data every 5 minutes, so the TTL might seem extraneous. Well, why would you have the TTL? Well, the advantage of still having that long TTL is to catch application bugs or something that crashes on your side. Your job ranker process crashes or something else, and it's not updating. Well, you still then, your cache gets flushed, and then the lazy population aspect can actually refill that cache. So these are strategies you kind of use together, and it depends on the different type of data access. And they're all kind of, there's no one single, like only do it this way, but through a combination of these different approaches, it really helps optimize your cache. And this is just showing how it's abstracted away still, same as before. So last major strategy, and then talk a little bit about Redis and some other aspects of ElastiCache. Timed refresh, as I mentioned, leaderboard. Maybe you're periodically updating the top 100 people, maybe the most interesting news stories, stuff that's trending up, stuff that's trending down, top tweets or something like that. It makes the most sense when you're spanning multiple different records, right? That's kind of one of the key decision points here. When you're spanning multiple different records, pulling from all these different sources, that's a great time to use a timed refresh. If you try to do that through lazy population or something like that, you're going to really impact a few users, or maybe even dozens or hundreds of users when they come, and that cache is empty, and then all of a sudden you're having to make dozens and dozens of calls and re-rank stuff. So a timed refresh is definitely a great way to handle that kind of data. Top N list, as I mentioned. Time-intensive processes, especially if it's something that takes more than a few milliseconds, if it's more than a database query, if it's actually like, hey, take this and do select and order and et cetera. That's a great candidate for timed refresh as well. Trending items, as I mentioned, these are all great strategies. And so the point of this being that there's just no one silver bullet, right? I can't give you a slide, unfortunately, that says, only do this, your caching will be good, move on, and then you're done. It's really a combination of strategies that depends on your data access patterns. So with that covered off, I want to kind of change gears slightly and talk about another feature of ElastiCache, which is monitoring and alerts. Make sure this doesn't happen to you. So as I mentioned, monitoring, ElastiCache integrates with CloudWatch, CloudWatch being our monitoring solution. And there's a whole bunch of metrics that ElastiCache is feeding into CloudWatch constantly, on your hits, on your misses, et cetera, et cetera. And so what you can do is you can set up alarms on each of those, and you can send them via email, text. You can do programmatic stuff on it, which we'll talk about. So you could have an alarm that says, hey, based on, if I get this many cache misses, then send me an alert, because it probably means something's going wrong. I shouldn't be, having over X% of cache misses. And the plugin into CloudWatch is how you accomplish that. So two good ones to look at are memory usage and evictions. So memory usage is self-explanatory. So memory usage is just how much you're using. It's not necessarily a good one to do an alert on. And the reason why is both Memcached and Redis just expand to fill all available memory, like any good software program, And so if you do an alert and you say, hey, if Memcached is using more than 90% of my memory, please let me know, it could be a great situation. That means a very optimal cache, right? You're using all your cache memory, It's not really something you want an alert on. Evictions, on the other hand, is something that actually says, hey, me as a process, Memcached, Redis, I'm actually out of memory. I'm doing my own memory allocation, my slab allocator, what have you. And I realize now that I don't have space for any more keys, so I had to flush 100 out. So evictions is one that is definitely a good idea to keep an eye on. Now, there's some more recent caching strategies. Actually, Rails 4, DHH made a great kind of blog post about Russian doll caching, which is essentially embedding. As I mentioned, there's different tiers, right, we've been talking about. And when you talk about the concept of partials, HTML, and such, the challenge there is trying to figure out how does the overall page expire, right? And when you're using Russian doll caching, the idea is that you just don't care about whether or not you have excess stuff in your cache. You just kind of keep filling it up and then let Memcached flush it out via evictions. I think the jury's still out on how that's going to actually perform in production. It's actually an interesting strategy. And the 37 Signals guys know what they're doing. But at the same time, anytime you're doing evictions, anytime you're doing cleanup, then you have a background process that's taking away processing, right? And you can get spikes in latency as it's going through and it's saying, oh, let me look at the least recently used, the LRU keys, and let me get those out of memory. And so you're going through all this list, and then that's taking away cycles that you could be using actually serving your cache. So long-winded way of saying evictions, if you're using the kind of standard, for lack of a better term, or at least the patterns we've been talking about thus far, then evictions you can probably alert on it at a fairly low level, right? You could probably set an alarm on evictions for maybe 10 or 100. That would mean that you're out of memory, right? If you're doing one of these, Russian doll caching or one of these that actually relies on evictions, that threshold could be higher. So it's going to vary a little bit. Me personally, from a gaming perspective, Russian doll caching wouldn't have a lot of application. If you're not familiar with it, just Google it and you'll be able to find write-ups on it. So I would, if I was setting it up for evictions, I would probably set a low level like 100. If I'm getting 100 evictions, that means something is definitely wrong. Send me an alert to my email or phone or whatever. And we actually have some guidance on our documentation as well. These will be up on SlideShare, so you'll be able to click on these actual links. But that's the title of the article if you just want to search for it as well. We actually talk a little bit about each of these and say, what are different things to take into account when you're monitoring these? So here's what the actual CloudWatch console looks like, if you haven't seen it, for ElastiCache. At least what it used to look like. We just updated our CloudWatch console. So what I've done here is I've gone into my cache, my cleverly named cache cluster, and I've just selected both of them so I get them both on a graph. And what this graph shows is I'm using the Dolly client. I'm using it with consistent hashing, so I just started jamming a whole bunch of keys in there. And as you can see, the orange and blue lines are pretty much the same, which is a good sign. That means I'm getting really good distribution across my two nodes because I'm doing that. And this shows, CPU utilization, network bytes out. Other metrics that are interesting, you see that the freeable memory there is declining, which again, not necessarily a bad thing, right? Filling up your cache memory is a good idea. You're making best use of the instance. So say I want to send an alert on this. What I actually do is I click on this View All, which takes me to the CloudWatch part of it. And then this is the Create Alarm wizard pane thing. So first step is to go in here and search for evictions. That's what I'm going to trigger off. I think it's a useful metric. And then I can see that it found my cache, and it found the metric name evictions. Click Continue. Give it a name and description. Just say, hey, high key eviction rate. And then this is where I actually build the logic in, right? I say, OK, if it's greater than or equal to 100 for 5 minutes, then that means something's going quite wrong with my cache. I want to be notified. Continue to make this happen. And then what I do is I subscribe it to an SNS topic. So way back when, slide 2 or 3, when I was mentioning firing up the cache cluster, I created that SNS topic called Cache Alerts. It's, again, very inventive name. So my Cache Alerts topic then, I subscribe this to that topic. Have to make sure to hit this Add Action button, which is easy to miss, and then click Continue. And this is just a confirmation page. And it shows, hey, yes, the metrics, that's correct, and then create alarm. So the nice thing about routing it all to that one SNS actual topic is then I can have one central place where I can route stuff. I can route stuff from there to my cell phone, et cetera. And then so automatic alerts that ElastiCache automatically sends, right, in terms of node health issues or something like that, are going to that topic. Stuff that I've set up myself is also going to that topic. And then I have one place where I can manage how I want to receive those alerts. It's really convenient. So we're scaling up, scaling down nodes, adding and removing them. I want to talk about how do you actually do node discovery. SNS topic, as I mentioned. And then you can actually have your app listen for events on that topic. You can have your app actually listen to an SNS topic directly, or you can do something like have it connected to an SQS queue and have a background EC2 instance that's just listening for events on that queue and then taking action. So these two actions are kind of the biggies. That means a new cache node has been added. It means a cache node has been removed. So there's situations, you want to have some programming logic there in order to reconfigure your client app so that that way it can connect or no longer connect to those cache nodes. Reconfigure connections, just mentioned that. And then you can, of course, set up event notifications. Again, that's a link to the documentation. It gives more step-by-step. Here's how to actually set up SQS and SNS alerts. And so what does that look like graphically? We've got our application here. We've got SNS, which is our topic over to the side. New cache node comes online, either because I got an alert and spun it up or whatever. So SNS will actually deliver an alert. In this case, we're just having the app directly listen to an SNS topic. But again, you could have an SQS queue and have a different EC2 instance, which is a very popular pattern. For the simplicity of this slide, I wanted to kind of keep it simple. So you actually get an alert that says, hey, node was added. And then you can have your app reconfigure and say, oh, OK, cool, now I know about this new cache node. Rinse, repeat, another node comes online. Same thing, hey, new node. App reconfigures, and then it can make use of the new cache. What does that look like in code? So node auto discovery. If you're using so from a manual perspective, you can just listen. If you're programming in, say, Ruby or whatever language, you can listen for those events. And then if you think back to that Ruby Dolly example, you would just have to have your application code reread, reinitialize the Memcache, do another memcache.new, if you will, with a new list of servers. But we also support natively the ability for our PHP and Java client libraries, our kind of official ElastiCache libraries, which are built on common open source libraries that are out there. They just add a little extra functionality. We actually support the ability to do auto discovery. So when those nodes come up, your application can actually dynamically detect them and start using them. If you're using Java or PHP, I would highly recommend you use the official ElastiCache library, or at least evaluate it, see if it's going to work for you. So in code, sorry, wrong button. What that looks like is rather than taking the individual nodes, when you're configuring your Java or PHP library, rather than taking the individual nodes, you grab the configuration endpoint. If you look at the dashboard, that's the one in the upper right-hand corner that we clicked on to get that pop-up. Rather than clicking on it and then taking the DNS points, we'll actually use that thing that we would click on, copy-paste that. And when creating the actual Memcached client, we set up dynamic client mode. This is a PHP example, obviously. It says, OK, yes, you're doing dynamic discovery. I'm giving you the endpoint. And then from there on, sorry, glossed over that. You add the server, which is just that server endpoint. The same thing I already talked about. That's what the code looks like. And then from there on, you just set and get keys. And literally, that's all you have to do. The PHP client will detect when you add and remove nodes. So it's very powerful, very convenient. If you're not using PHP or Java, then you would do just listening for those SNS events, reconfiguring your list of servers, and reloading that handle to Memcache. All right, so that's kind of ElastiCache functionality as a whole. I want to talk about Redis, one of my favorite topics, save for the end. So how does it compare to Memcache? It's also in memory, right? It's got more advanced data types rather than just set and get. You can do stuff like lists. You can do stuff like sorted sets, which is really interesting for gaming. It's actually a set that is pre-sorted in real time. So you can get a top 10 leaderboard, and I'll show you an example of that. It's also got atomic operations on all of these data types, which is the most powerful part about it. So if you think about the common case when you want to just add people to a list, if you're using a relational database, it can get a little tricky, right? You have to do some certain locking to make sure different people aren't getting on a list, et cetera. It gets a little bit database intensive. It can make your database unhappy. With Redis, it's just these simple data types. You've got a list. You can just pop people onto that list, push them off like you would a data structure that was in memory. It is single-threaded, so it doesn't have the advantage to be able to take advantage of multiple cores like Memcached does. Doesn't make a huge impact in a lot of real-world usage, but it is something to be aware of because when you're talking from a monitoring perspective, and we cover that in that link I showed you about monitoring ElastiCache, you'll see very different CPU performance out of Memcache and Redis. So it's something that on Memcache might look okay, it could be a problem on Redis and vice versa. So that's covered in that link. And again, if you search for it, it's just called ElastiCache, what metrics should I monitor? And it does have persistence, which is cool, unlike Memcache. And it has the ability to do read replicas. So here's an example of leaderboards, something you can't do with Memcache. So you can just add people to a sorted set, which is kind of like a pre-sorted hash almost. And you give it a numeric value, integer, whatever, and then you give it the key value. And then when you do a Redis operation out of zrev range is the technical actual operation you do, it'll give you that pre-sorted. It's sorted in real time. It's amazingly powerful if you're talking about, hey, give me alerts, or give me, not alerts, but the most recent events that people are doing. Give me an event stream. Give me stuff that's trending. Give me the top 100 people. There's a lot of power in this. And then you can give a rank directly for a person as well. How does that translate to code? And kind of in going back to our canonical example of saving a user, we want to actually, he just got a new score, so we want to update his score in the leaderboard. That contacts Redis via ElastiCache. Get the rank, zrev rank +1, because it's 0 bounded. And then we can save a whole bunch of values, and we can get the rank for Barry. So it's pretty cool. If you're using Redis already, you're probably thinking, yep, I know that, and that's awesome. If you haven't used Redis, there's lots of applications for this. Highly recommend you check it out. So Redis has the unique capability within ElastiCache to do read replicas that Memcache doesn't. So when you actually configure a Redis node in ElastiCache, you can set up a replication group. And that's what this shows. And what that does within ElastiCache is that will actually replicate your data then from your main node to your secondary node, your replica. And then if something fails, you can make use of the replica. So you have an up-to-date copy of your data, at least reasonably up-to-date. It's asynchronous. That's just the way Redis replication works. Similar to MySQL replication, it's asynchronous. So it's not a strict guarantee that you're going to be up-to-date, but you'll be pretty close. And it's much better than starting with a totally blank cache, which is what would happen if you have a Memcache node fail. And if you really want to get optimizy about the whole thing, right, you can set it up so all your writes go to your main node and all your reads come off. There's a lot of caveats there. If you've ever tried to do this, your data is always going to be just a little bit out of date. So it'll work for some data. Like if you've got your top 10 leaderboards or whatever, that would work here because maybe you're only refreshing it every 5 minutes. If you're talking about, hey, I want to get my up-to-date position in something, probably not the best to do this because you're going to be a little bit out of date. As a person goes page to page through your app or through your website or whatever, they're going to get different data. It could be a little confusing. And so a few more topics here. Redis sharding. So the same concept of Memcache that we talked about earlier, right? Is that consistent hashing, distributed across, check your client library, just make sure it supports it. A lot of them do. Huge but in blinking red. You cannot shard those more advanced data types in Redis. It's not possible. It's a limitation of Redis. And the reason why is because in order to do this real-time in-memory sorting, you need the entire thing in one in-memory structure, right? You can't do an in-memory sort across multiple nodes, right? Seems to make sense. So when you talk about stuff like lists, sorted sets, et cetera, you're going to wind up, instead of this very sharded, horizontally, just kind of automatic approach, you need to take a little bit more thoughtful approach, and you're going to have to start splitting things up by actual usage, by what they're actually trying to do. And that's kind of our big anti-pattern to this talk, which is having dedicated nodes for different purposes when you're using Redis. So you would spawn multiple nodes in that same pattern I showed, but then rather than just spreading everything across them all, you're going to need to have your application use them for different features. So you might have one node that just does your leaderboards. That way it can sort them all in memory. You're going to have another node that maybe does all your counters, the number of people that are in game, or the number of people that are on a given site, what have you. Those are all on one node. Anything where you have to do those kinds of operations on a single structure, they need to live on the same node. Now, for any of the key value stuff, you absolutely can still shard it across. So if you decide, hey, I just want to go all in on Redis, I don't want to manage Memcache and Redis and do Memcache for some stuff and Redis for the other, which completely makes sense. A lot of people do that if they're using Redis. They just use Redis for everything. So you can absolutely spread across your kind of standard key value stuff, which is basically identical between Memcache and Redis nowadays. You can do TTLs, you can do set and get and conditionals. All that stuff is basically identical. So you can shard that kind of stuff, but not those more advanced data structures where you're relying on sorting, where you're relying on it, for example, enforcing uniqueness, which is what Redis sets do. They force, uniqueness, for example. So what does the dedicated Redis node concept NI pattern look like? So we're adding more cache nodes, kind of looks similar to the Memcache example. But rather than those being, you can see at the bottom, some of you in the back might not see it, just rather than those being just all the same, we're going to dedicate those in our app code to say, hey, this is just for leaderboards, this is just for counters. And then any of these can then be put in a replication group as well. Right? So if you can imagine this replication group being on all three of those main nodes, you can have essentially different vertical slices of stuff you're doing with your application, each with a master and a replica. And it's a great way to have that data there, have it fresh, have it available. Cool, so wrapping up, and hopefully I have a few minutes here for questions. So caching is good, do caching, right? Really getting really good at it is difficult. Right? There's no silver bullet, there's no any one thing you can do. Hopefully this gives you some ideas, some insights, and different patterns you can use and mix and match. ElastiCache helps with the deployment aspects of it, simplifies a lot of that alerting. You're still going to have to take steps to then make use of good caching strategies and try to share some of those with you today. We support Memcache or Redis out of the box, and then keep an eye on this space. We're definitely looking at really doing some cool things with caching. And along those lines, as I'm sure you've heard ad nauseum at this point, we're a very customer-centric company, sincerely. We thrive on customer feedback, so if you're doing a lot of caching, you have feedback, or you're a Redis fan, and you want to give us input, we'd love to hear it, what you'd like from ElastiCache going forward. All right, cool. So, thanks. That's my talk. So we got a few minutes for questions. Try to see over the blaring lights here. Yes, up in the front. Persistence. Oh, sure. So the question was, talked about persistence for Redis. How does Redis implement persistence? Yeah, I kind of failed to mention that. So there's two different strategies that Redis does for persistence. One of them is called RDB, or BG save. That was the original one. Essentially what that is that on a time interval, say every 60 seconds or 3 minutes, whatever you configure, it just takes whatever is in memory and snapshots it to disk. Okay? The other strategy is called AOF, or append-only file. That came later. And what that does is it's much more like a database redo log. That is, every single thing that you put into Redis, it actually writes to disk, so that way you have a full log of the transactions. AOF is what ElastiCache implements. If you're doing it on your own, you would have the choice of doing either one. AOF offers a little bit better resilience. You don't have a time window when you can lose data. So those are the two strategies that Redis uses. Yeah, question?
Given that Memcached is multi-threaded and Redis is single-threaded, do you have any recommendations on particular instance types to use for those situations?
Yeah, good question. So the question was, given that Memcache is multi-threaded and Redis is single-threaded, how does it impact the types of instances you might choose for either engine? It is a great question. If you look at, I think, the driving factor for instance selection, at least currently with the way that the platform works with ElastiCache, is really going to be the amount of memory that's available on an instance, is figuring out like how much memory you actually need on a given instance, specifically for Redis. So even if you're trying to say, OK, well, I don't need 4 CPUs, for example, but I need 200 gigs or whatever of memory, you're going to kind of be bound. We have a good amount, good variety to choose from, but at some point, if you need to fit an entire 10 million people in one memory image, you're kind of just going to have to go with that biggest instance. So in instance selection for Memcached, you can kind of just engage it based on when you want fewer nodes or more nodes and how much you want to scale in or scale out. So that's kind of the decision point there. With Redis, it's going to be bound on how much data, how much space do you need for your data. So, yeah, question? That is a good question. Honestly, I do not know the answer to. And the reason why I don't know the answer to that is actually ElastiCache takes care of managing that for you. I don't know if under the hood if it's using EBS or if it's using ephemeral with snapshots to S3. Both of them work well. I don't know what it's actually doing. Yeah, it takes care of managing the persistence for you. So, other questions? Yes, in the back. Yeah, good question. So the question is, since you can't shard the advanced types with Redis, how do you handle the case when it's actually filling up? So really your only option, and this is not anything with ElastiCache, it's just the way memory works, is to go to a bigger instance at that point. And so you can go through ElastiCache and you can allocate a new instance that would be larger, and then it would be a matter of actually populating that data. I don't know offhand whether or not you can mix and match right now. I know that there's new innovation we're looking to push in that place in terms of being able to make that more seamless for you. But right now the procedure would be to do a bigger instance and then essentially move over to it. That's your solution. Yeah. Right. Yeah, so the question is if you want to use Redis in both ways, if you want to both have the big single memory image for some of your stuff, but also do the sharded key value just so you only have one tech, how would you set that up? Yeah, if it were me, I would do just separate nodes of maybe a smaller instance type for all the key value stuff and just shard it across those, and then have a separate 1 or 2 or however many n nodes you need to handle the big structures that you can't shard out. Yeah, I wouldn't try to mix them and match them on the same instance. I would keep those 2 separate. Yeah, question? Yeah, great question. So currently the way it works is that each node is going to replicate independently. So it would be possible that you would have slightly different stuff in the replicas at a given piece of time. Again, if you're following that pattern and you're doing the lazy population and all that kind of stuff, when you're talking about sharding the key value space, that use case, then that'll just kind of work itself out in the case that you have to fail over to a replica. Okay, probably got time for one last question. All right, yeah. Across AZ, yeah. In terms of the replicas, or in terms of? Is it just one instance? Right, so ElastiCache is very similar to RDS, the relational database service, and that it helps the management aspect, but ultimately you're deploying a node in a given availability zone. So when you're deploying it, you can choose which availability zone or zones to push your different nodes in. But yeah, it's not like DynamoDB, which is a fully managed service up at that layer where it's kind of a black box. This is more a convenient way to manage that, but you're still choosing where to push your cache nodes. So I think that's all the time for general questions. Feel free to grab me, though, after. Thanks a lot. Appreciate it. Good. Oh, nice to meet you. Let me turn this off. Yep.